Now let's see chapter 14, Organic Chemistry, Homologous Series, Family of Similar Compounds with similar properties due to the presence of the same functional group. So example will be Alkane is a family or a homologous series, or Alkene is also a homologous series. It's also a family or a groups of members with the similar chemical properties. Alcohol is another homologous series, carboxylic acid, and so on. So characteristics of a homologous series: all the compounds fit the same general formula. So for example, just now I said alkane, right? So alkane is a homologous series. All the members under alkane, they fit this formula, CnH2n plus 2. All the alkene will fit another general formula, which is CnH2n. The chain length increases by 1 each time. So the chain length here refer to the carbon. The carbon increase by 1 each time. So for example, alkane. So you know alkane is CnH2n plus 1. So the first member you substitute n with 1, then you will get CH4. So the second member you substitute with 2, then you get C2H. 2 times 2 plus 2 is 6. Okay, so C2H6. So you can see here the chain length increased by 1 is where the carbon increased by 1. Okay, not the hydrogen, but the carbon. The carbon represent the chain length. As the chain gets longer, the compound shows a gradual change in properties. So for example, if you have greater intermolecular forces and hence higher boiling point and melting points, structural isomers have the same chemical formula but different structures. They can be straight or branch. Okay, so for example, let's say C4H10, it shows structural formula. It can be C in a straight chain. Then the rest are hydrogens, like this. This is one of the possible structures under C4H10. So beside this, it is possible to form CCC with a side chain in this particular position. So 1, 2, 3, 4. Try to see something like the number of covalent bond for carbon is always 4 covalent bonds. Okay, so this is the example of structural formula where the C4H10 can show a straight chain of 4 carbon or a straight chain of 3 carbon followed by 1 carbon at the side branch. So that is structural isomers. Then we look at fuse. Fuse to know coal, natural gas, petroleum. Okay, so coal, natural gas, methane. Methane is CH4. CH4, the first member in alkane. Petroleum is a mixture of hydrocarbon. So the hydrocarbons are actually the alkane and the alkene. So these are the hydrocarbon. As you can see, there are only 2 elements, which is hydrogen and carbon. So it's a mixture of different kind of hydrocarbon which can be separated into fractions. So through distillation, so we can separate them into components. Like you can separate into petroleum gas, petrol, Then diesel, bitumen, okay, can separate them into members. Kerosene. Okay. Now, just now we missed out this part. Let's take a quick look. Each homologous series has the following properties. Members of the same homologous series can be presented by a general formula. So this one we have discussed already with two examples. Members of the same homologous series can be prepared by the same method. So for example, you want to prepare alkene. One of the way is you do dehydration of alcohol. So it happens to all the members in alkene. All the members in alkene can prepare through this way. Okay, so members of the same homologous series exhibit similar chemical properties. So for example, all the alkane undergo free radical substitution. So that is one of the example. Okay, so all the alkene undergoes addition reactions. So that is another chemical properties. So member of the same homologous series have the same functional group. So for example, alkene, the functional group is the CC double bond. So all of the members under alkene have CC double bond as the functional group. Functional group means the group involved in chemical reaction. Okay, so each member in the homologous series is different from the subsequent member by a CH2. So you can see from this member to the next member, right? This is addition of 1 carbon and 2 hydrogen, CH2. Okay, so that means if you want to continue, you add CH2 to it, then you get C3H8, which fulfill the formula here with N equal to 3, C3H8. Okay, so we have done the homologous series there. Now let's continue with where we stopped just now. The uses of petroleum fractions. So just now they said petroleum is a mixture of hydrocarbon, right? So you can separate them into the following fractions. The first one is refinery gas, bottle gas for heating and cooking, gasoline fractions, petrol in cars, naphtha fractions, making chemicals, kerosene or paraffin fractions, jet fuel lamps, diesel gas oil fractions, fuel in diesel engines, fuel oil fractions, fuel in ships and home heating system, lubricating fractions, lubricants, waxes and polishes. Bitumen is to make road. So these are the fractions that you have to remember. Name of compounds, name ending, compound type, name. So that means what? That means, for example, alkane, end with A-N-E. Alkene, then the back of the name is E-N-E. Alcohol, the back of the name is O-L. Carboxylic acid, the back of the name is oic acid. Ester, you will see YL followed by OH. So we'll see example later. Okay, let's go through the homologous series over here. So alkane, the functional group is CH. The general formula is CnH2n plus 2. The chemical reaction is free radical substitution. Combustion. Catalytic cracking. Okay, so what kind of reaction are these? Just care about it later. Okay, so we just fill out in general first. Okay, alkene, the functional group is C double bond. How is it? we discuss later. Now we just filled out the blank without understanding much without discussing much on all this. CnH2n. Chemical reaction is addition reaction, combustion also. So alcohol, the functional group is the OH. General formula CnH2n plus 1, OH. So chemical reaction, we have oxidation. Oxidation of alcohol will form carboxylic acid, aldehyde ketone. Okay, so depends on which alcohol are we oxidizing. We also have dehydrations of alcohol to form alkene. Okay, so we can also do esterification with carboxylic acid. Okay, then carboxylic acid, the functional group is COOH. Okay, so general formula is CnH2n plus 1 COOH. Okay, so chemical reactions, is acid, right? So acid, that means all the acidic reaction. So the acidic reactions, like carboxylic acid with alkaline, with base, with carbonate, with reactive metal. So they can go through esterification also. That means they can react with alcohol to form ester. So that's why here you have esterification. Here you have again. After all, alcohol plus carboxylic acid become ester. So that's why esterification happen in two of these. Okay, so let's move on. We start with alkanes. General formula is CnH2n plus 2. When n equal to 1, it forms methane, which is CH4. When n equal to 2, it forms ethane, which is C2H4. N equal to 3, it forms propane, which is C3H8. When n equal to 4, it forms butane. Butane is 4 carbon, so C4H10. So each carbon atom in an alkane has 4 covalent single bonds. This makes them quite unreactive. So you can see each carbon forms 4 single covalent bonds. So likewise, this one carbon, you can see 1, 2, 3, 4 covalent bonds. Okay, so the first reaction here is combustions. Complete combustions, that means enough oxygen supply, so water and carbon dioxide form. The example you see, methane react with oxygen, that is combustion. Combustion means react with oxygens. They form carbon dioxide and water. Okay, so when you want to write down the chemical equation for combustions, sometimes you may use this formula: CXHY plus X plus Y over 4 O2 become X CO2 plus Y over 2 H2O. By using this equation, you can quickly balance it. Okay? If you are not using this, then you have to balance it slowly. Okay? So incomplete combustions is where it has not enough oxygens to burn. So because of that, it doesn't form carbon dioxide only. It's also form carbon monoxide or carbon. So because lack of oxygen, so they form these two. So either carbon monoxide and water or carbon and water form. So the equation is not fixed. It depends on how much oxygen is lacking. If lacking moderately, they form carbon monoxide. Is lack of oxygen very much, then they form carbon only. Carbon is the black smoke. So that's why when you see a truck or a lorry, when they climb up the hill, then black smoke come out. Basically because they need to burn more fuel. When they want to burn more fuel, oxygen is not enough to the supply of oxygen is not enough, so that's why black smoke come up from the truck. So chlorine substitution, this is another chemical reaction which is called free radical substitutions. You need sunlight or light to make this happen. A chlorine atom replaces hydrogen atoms. So something like this. You see CH4 plus chlorine in the presence of sunlight or just light. So what happens is the Cl2 will change to chlorine atom. Okay, so one of the chlorine will go and replace the hydrogens, substitute the hydrogen. So that's why you see the hydrogens from 4 units, now it becomes 3 units. One of the hydrogen is kicked out and formed and replaced by chlorine. So the hydrogen which has been kicked out, which has been substituted, is now released and joined with another chlorine. So that's why there are 2 chlorines involved here. One is to form HCl, another chlorine is to stick to the methane. Okay, so of course CH3Cl can continue to do chlorine substitutions, then one of the hydrogens become chlorine, so that's why you see decrease in hydrogen by 1 unit, chlorine increased by 1 unit, and it continues. Okay? Hydrogen replaced by chlorine, so there are more chlorine and less hydrogen, and continued again, hydrogen replaced by chlorine, then it becomes CCl4. So the name CH3Cl chloromethane, CH2Cl2 dichloromethane, trichloromethane, tetrachloromethane. So that is the thing. Catalytic cracking is not explained here. So in the note, I put catalytic cracking. So actually that is the breaking of alkanes into smaller alkane as well as alkene. That is cracking. So cracking is long chain alkane break down into short chain alkane and alkene. Okay, so that is cracking. Now we look at the second homologous series that we are going to go through is alkene. General formula CnH2n, functional group CC double bond. We don't have members for all n equal to 1 because in order to form CC double bond we need at least 2 carbon. So the first member is hence ethene, 2 carbon. You can see CC double bond. Propene, 3 carbon, CC double bond is there. Because of the double bond, right, you can see the carbon takes 4 bonds in this way. 1, 2, here count 2 already. 1, 2, 3, 4. So they take 4 bonds in that way. Okay, so bit 1 in is where the 1 represent the positions of double bond. So you call this 1, 2, 3, 4. So one in means double bond in the first carbon. Cracking. So cracking is the thermal decomposition reaction in which an alkene and sometimes hydrogens are produced from an alkane. So the one that I explained just now. Okay, so a long chain alkane break down into alkene, break down into alkane, but they are short chain. After that breakdown, it becomes a short chain, alkane or alkene. Cracking always produces short chain compound with a CC double bond. So that means cracking always produce alkene as one of the product. Alkene must be there. Is alkane is a must product or compulsory to be the product? Alkane no. Okay, alkane no, but alkene must be one of the product. So example, decane, 10 carbon, 22 hydrogens. Octane, 18. So you can see they found alkane, alkene. Alkene must be there, like what I said. Okay, let's see another example. Cracking. Okay, ethane, 18 hydrogen. Dodecane, hexane, 18 butane. So you can see no alkane for this. Alkene is there. Alkene is there, alkene is there, alkane is there. Hydrogen is not there. Icosane change to octane, propene, nonene. So you see they always form alkene. Alkane optional one. Okay, so that means let's come back to the notes. Alkene, alkane, hydrogens. So optional, these two. This one must. Okay. What alkene must it form? Flexible one. Okay, flexible. Or I should say it happens randomly. It happens randomly. So you must form any alkene followed by alkane or followed by hydrogen. Just like that. Now let's see the pictures here. Cracking of ethane will give ethene and hydrogen. So how? You see mineral Wu soak in hydrocarbon. So this is where you have the ethane. Okay, then you heat up the porous pot or the aluminum oxide. Cracking happens, mixtures of alkane and alkenes. So the alkenes form is ethene, C2H4. Okay. This is a different equation compared to this. They use butane. Butanes crack and form ethane and ethene. So C2H6 and C2H4. So which will come here. Saturated hydrocarbons have no double bond. So this is alkane. Do not react with aqueous bromine. So the mixture stays orange. Okay, so that means you add aqueous bromine. Aqueous bromine is orange color liquid. You add to it, no reactions. Okay, the orange color remains. That means the bromine remains there. Unsaturated hydrocarbons is the one with double bond, so it's alkene. So it reacts with aqueous bromine, turns the mixtures from orange to colorless. So this is addition reaction that we filled in the box just now. Orange to colorless. That means bromine is reacted already. It's not in the form of Br2 anymore. So it sticks to the alkene already. So that's why it changed color from orange to colorless. Okay. So we have addition polymerizations. This one we can add to the alkene just now. So addition, combustion, addition, polymerization. So you can add this as well. Okay, this has been left out. So what is addition polymerization? So you can see here. Okay, addition polymerization is alkene join up together to form a very long chain polymer. So that is addition polymerization. After they join up, right, you can see the double bond no more already. So the double bond is going to the side way already to link with other members. So that's why the double bond is not there anymore, as they form single bond with members on the left as well as members on the right. So a polymer is a compound with very long carbon chain made up of monomer units. So the monomer join up. Monomer had double bond, polymer no more double bond. So example, polyethene. Polyethene is where the ethene join up and it becomes polyethene. This is polyethene. After join up, we call it polyethene. Although the name is ethene, but the double bond is not there anymore. So polyethene also can. It's a polymer produced from ethene by addition polymerization. Double bond split sideways, and polymer is formed. Now we see addition reactions. So addition reactions means you add something to the double bond. Okay, so the first one, CC double bond, you add bromine. You add bromine. Bromine is Br. So what happens is one Br come to this carbon, another Br come to this carbon. So you form CBr, CBr, Br. With steam. So of course you have to know this is brown or orange. Brown or orange. So after addition it becomes colorless. So that's why the observation just now is still here, orange to colorless. So with steam, steam is where the double bond react with H2O, water. So one carbon will take H, another carbon will take OH. So take H, take OH. Okay, so ethene, for example, react with steam, then the double bond no more, they become single bond, then it takes OH. OH is alcohol. So that's why ethanol here, which is alcohol, is formed. So you want to have these reactions to happen, so you have to heat, you have to have pressure and a catalyst. Okay, so what catalyst no need to remember. What pressure no need to remember, just write in general, heat, pressure, catalyst. Okay, now with hydrogens, double bond breaks down to form an alkane with heat, pressure, and catalyst. So again, no need to remember the temperature, like 180 degrees Celsius, no need to remember. Pressure, no need to remember what value. Catalyst, nickel, right? Nickel, no need to remember. So just write catalyst only. Okay, so ethene react with hydrogen. Hydrogen, you take it as HH. So one of the H come to this carbon, another H come to the other carbon, so they form H, H, and the rest. So this is alkane, alcohol. This one is what? This one is 1,2-dibromoethane, for example. Okay, so dibromo. Now we look at the third homologous series, which is alcohol. General formula CnH2n plus 1 OH. Functional group is OH. First member methanol, 1 carbon. ethanol, 2 carbons, propanol, 3 carbons, butanol, 4 carbons, formed by fermentation. The fermentation is the traditional way to make alcohol, to make wine. Okay, so enzyme in yeast break down glucose to ethanol and carbon dioxide, giving out heat. So this is the fermentation process, traditional way to make wine. So for example, you put yeast with rice, and then they will form wine. Okay? So the wine is actually the productions of alcohol with others. Or maybe you put yeast with grapes, then they will form red wine. So it can be done with substances that contain cellulose, starch, or glucose, like rice, like grapes. Okay, so done by grinding sauce, example grapes. You grind the grapes and then you add enzymes to break down the cellulose and starch into glucose. Leave it to ferment, that means you leave it without oxygen with yeast. Okay, so the yeast will change it to alcohol. Fractional distillation is used to get ethanol from the mixtures. So if you want to get ethanol, you want to get pure ethanol from the mixtures, and then you do fractional distillations. Okay, so this is the traditional way, but we have an alternative way to form alcohol. So which is catalytic addition of steam to ethene. So as you can see, ethene plus steam become alcohol. Alcohol has OH there. Okay. Ethene is obtained by cracking long chain alkene from oil. Okay, so cracking, you want to get ethene, you can crack the alkane. Then the ethene react with steam in a reversibly way in the following condition. 170 degrees Celsius, no need to remember. 60 to 70 atm, catalyst is phosphoric acid. Yeah, so like here, no? Just take it as heat pressure catalyst. What heat? 150, 70 degrees Celsius. No need to remember. Pressure, no need to remember. Catalyst, phosphoric acid, no need to remember. So no need to remember. Just write in generally. You need heat, you need pressure, you need catalyst. Low temperature give a better yield, but high temperature is used to give a better rate of reactions. So this is the equilibrium problem. So if the temperature is low, then the equilibrium is to the right. You have a better yield. If the temperature is low, but you get a better yield for a very long time, you need to wait for a better yield. Okay, the rate is very slow. If you use high temperature, then the yield is very low. That means the percentage of product is very low, but you get it quickly. So that's why you need to find a best temperature under where you get it quickly, but the amount of product is acceptable. So that's why after the trial, they set up this as our the best condition to get most product in a short time. Okay, now you see advantages and disadvantages. Fermentation, renewable source, good use of waste organics material. Imagine too much grapes, cannot finish, then change it to red wine. Okay, so that is the thing. Lots of material needed, so big tanks needed. So you need a big tank to do fermentations. Fractional distillation is expensive if you want to get if you want to get ethanol from the mixtures. It's a slow process, so you have to wait for a long time to get enough alcohol or wines. Batch process, so I have to do batch by batch. So like this year, you know, when you buy wine from shop, so you may buy wine of a particular year, and so on, you know. So they do batch by batch. Compared to the additions of steam, this is fast. Okay, so this is a continuous process. No need to do batch by batch. Just keep doing 24 hours to produce ethanol, pure ethanol. You get pure ethanol. Okay, so although they say reversible, seems like the ethanol can react backwards to form ethene, but that is somehow the way to get pure ethanol. Compared to this one will have a lot of glucose that stick together with the ethanol. So this is purer. Although there is still ethene there, okay, it's pure compared to this one. Smaller container required. Compared to this one, you need a big tank. Okay, this one just a smaller container. Oil is a non-renewable resource. So the oil here is the ethene. You know, ethene comes from alkane from oil. You know, so from oil, the petroleum. Okay, so it's non-renewable, can finish on lots of energies to make steam and get right conditions. You see the conditions. So need a lot of energy to do that. Need a lot of electricity to press to form this high pressure. Need a lot of electricity to heat out into this high temperature. Okay, so lots of ethene is unreacted and then recycled. So you know there are reversible reactions, so they don't 100% change to ethanol. Some remain as ethene. So you have to reuse or recycle it to reform ethanol. Okay, so ethanol burns well in oxygen, giving out plenty of heat as well as carbon dioxide and water. Okay, so you will see ethanol is used as a solvent to dissolve things that water cannot. Okay, so this ethanol, you know, the structures is C2H5OH. So it can dissolve the OH group here, can dissolve the substance that used to dissolve in water, water soluble. The C2H5 is the substance which dissolve in organic solvents, can dissolve in ethanol because of the presence of C2H5. Okay, so that means it has two parts which help to dissolve, which help ethanol to act as a good solvent. Okay, so those substances that are water soluble can dissolve in ethanol because the presence of OH. Those substances that cannot dissolve in water but can dissolve in organic solvent can dissolve in ethanol also because of the presence of C2H5. So that's why ethanol is a very good solvent. Evaporate easily. So ethanol can evaporate easily. So used as solvent in glues, printing inks, and perfumes. Okay, so fuel added to or instead of petrol because it burns cleanly. Okay, so no need to have problem like sulfur dioxide come out. So we don't have this problem as it's clean. Okay, so it just forms carbon dioxide and water, so it's better. Now we look at the next homologous series, which is carboxylic acid. So carboxylic acid is, you can see the general formula, CnH2n plus 1, CnH2n plus 1, COOH. COOH is the functional group. Okay. Then the first member is methanoic acid, N equal to 1. Imagine you put 1 here, you will get C1H3. C1H3, yeah. 2 plus 1, 3. Okay, C1H3, COOH. Oh, that means N equal to 1 is not correct. So you want to get methanoic acid, of course, you have to put N with 0. N with 0, okay, you have to put N with 0. Imagine you put 0 here, right? C0H1, you will get HCOOH. So N equal to 0. To get methanoic acid should be 0, and because of that, this should be 1. Imagine you put 1 here, CH3COOH. This should be 2 then. Okay. Propanoic acid, you put 2 here, C2H5COOH. Okay. They put 1, 2, 3, 4. I think it's just to show the number of carbon only. Okay. So when you put into the formula, think differently. You put 3. So properties of ethanoic acid: weak acid with high pH. Weak acid with high pH. Although they say high pH, just remember that it is still below of 7, or else it is not acid anymore. Okay, so the high pH is still below of 7. For example, maybe the pH can be 5 or can be 6. Depends on the concentration of the acid also. Okay, but must be less than 7 in order to act as a weak acid. Okay, then the other thing is low dissociation. Dissociation is the important properties for weak acid. Strong acid dissociates completely. That means they change to ions completely, but weak acid dissociates partially. So dissociate partially is something like this. Let's say ethanoic acid, CH3COOH, dissociate partially. We use this symbol, showing that reverse reactions can happen. Some of them change to ions, some of them remain in molecules. So that's why we use reversible reaction to show no dissociations. Formed by oxidations of ethanol. So oxidations of ethanol will form ethanoic acid. With acidified potassium manganate 7. Okay, so this is an oxidizing agent which oxidizes ethanol to ethanoic acid. So this is oxidizing agent. Oxidizing agent. And we need to know this oxidizing agent is purple. So once you use it to oxidize ethanol to ethanoic acid, it will change into colorless. Carboxylic acid react with alcohol to give ester. So this one we discussed just now in the table. So in condensation reactions, for example, so why they call it condensation reaction? It seems like, condensation is the steam change into water. So that is condensation that we normally understand. So here the condensation reaction is a reaction which produces water. So you see, water is produced. So if water is produced, then condensation makes sense here. So let's see. This is where they form ester. Carboxylic acid, which is ethanoic acid, react with ethanol. This is alcohol. So carboxylic acid react with alcohol to form ester. Ester is ethyl ethanoate. So ethyl ethanoate. The ethyl here come from alcohol. If the alcohol has 2 carbon, you will see the word et. Then you change it to ethyl. The ethanoate here come from the carboxylic acid. So let me put different color. So ethanoate come from the carboxylic acid. So if this carboxylic acid is propanoic acid, then this one you have to change to propanoate. If the alcohol is, let's say, methanol, then here you have to change to methyl. Okay, so the alcohol affect this part. The carboxylic acid affect this part, the OH part of the name. Okay, so the alcohol will take YL at the end when they found ester. The carboxylic acid will take OH when they found ester. Water will form as well. In terms of its structures, so you can see some information like this. The carboxylic acid will remove the H, COOH, right? Will remove the H. The alcohol will remove the OH, so that H2O is taken away as a product. Then whatever taken away here, just join them up. The O will join with this C, so as you can see here, the O join with the C, and then they form ester. Okay, so now we practice ethyl ethanoate. The alcohol is ethanol, which is C2H5OH. Okay, let's say I follow the notes here. I follow their color. All the alcohol I use red. Okay, I use red. I follow the color up here. So ethyl come from C2H5, C2H5OH, which is ethanol. Carboxylic acid I do later. Okay, let's see this first. Propyl come from C3H7, which is C3H7OH, which is propanol. Methyl butanoate. Methyl come from the alcohol CH3OH, which is methanol. Okay, now the carboxylic acid. Carboxylic acid, I use blue color. You look at the ethanoate here, so it comes from the carboxylic acid, which is CH3COOH, CH3COOH, which is ethanoic acid. So to work out the structures, so we have to do something like this. Okay, so you draw the ethanoic acid first, CH3COOH. Then the ethanol you just swap so that the C2H5 is here, OH is facing the COOH, so that we can remove the H2O in this particular way. And then they form the product, which is CH3COO C2H5 plus H2O. Okay, so like that. Now for this one, you see methanoate. Methanoate is this part, HCOOH. HCOOH. Methanoic acid. HCOOH plus the alcohol. Like what I said, the alcohol you swap. So that C3H7 is at the right. OH is on the left, so that we can remove the H2O easily in this way. Then they form a product which is ester. Just join up HCOO with C3H7. Then another product is H2O. So like that. Methyl butanoate. Okay, the carboxylic acid is from here. C3H7COO. So which is C3H7COOH. Butanoic acid. Okay, then we join up C3H7COOH plus methanol swap. Take the OH on the left, so that you can take the H2O in this way. Okay, then they form C3H7COOCH3, the ester plus H2O. Okay, so the formation of ester. Okay, now come to this part, macromolecules. Okay, so macromolecule is large molecules. A large molecule is called macromolecules, built up from small units which are monomers. The monomers join up, then become large molecule. Large molecule is known as macromolecules. Different macromolecules have different units and or different linkages. So for example, the monomer glucose, amino acid, fatty acid, and glycerol. So seems like biology. I know glucose, when they join up, then they form starch. Amino acid, when they join up, they form protein. Fatty acid and glycerol, when they join up, they form lipids, or they form oil. Okay, so that is the macromolecules. So they may join up with what kind of linkages or what kind of chemical bonds. So they can use amide or ester. Okay, so in details, glucose, in detail, which use amide, which use ester, not so necessary to know. Okay, not that necessary for IGCSE. Okay, so what is the difference between amide and ester? So of course there is a difference. Amide is C double bond ONH. Ester is C double bond O and O. So the structures of the linkage looks different. Okay, so for example, they don't show. Okay, they don't show. Let's say this one, CONH, amide. This one, and this is amide. Okay, so let's see another example. Amide, CONH. COO, ester. Ester. So this is ester. Okay. Now let's see some example here. Polythene. Polythene we discussed just now is ethene. Use the double bond to extend the bonds sideways to form polythene. So polythene is plastic basically. Plastic bags, gloves, cling films. They are low density. They are soft plastic, in other words. Mugs, bowl, chairs, dustbin, they are high density. This is hard plastic. So polythene can form soft plastic as well as hard plastic. Okay, so polychloroethane, PVC. Water pipes, Wellingtons, hoses, coverings for electricity cable. Okay, so the insulator cowling, so they are made of PVC. Okay, so PVC is ethane with a chlorine that substitute the hydrogen. As you can see, this is hydrogen, now replace with chlorine. Okay, so PVC. Polypropene. Polypropenes, you see propenes here. Propenes is 3 carbon, 1, 2, 3. Okay, 3 carbon. So you put the third carbon sideways, the double bond, just put it in the center, then the double bond extends sideways in this way. Okay, so crates, ropes, so that's the usage. Polystyrene, used as expanded polystyrene in fast food cartons, packagings, insulations for roof and walls. Okay, so polystyrene, white color one. Okay, so the monomer is phenylethane. Phenyl means there is a hexagonal shape here, C6H5, phenyl, benzene ring. C6H5 is phenyl. Double bond put in the center. By the way, C6H5 is the benzene ring. So it's like this one. C6H5, benzene ring that stick to CC double bond. Okay, so it's this structures, phenyl. Okay, the double bond extends sideways to form polystyrene. Then you can see Teflon. Teflon is the coating of the non-stick pans. So coated on flying pans to make them non-stick. Fabric protector, windscreen wipers, flooring. So Teflons, you can see fluorines replace the hydrogens of the ethene. So then the double bond put in the center and extend sideways. So all the examples shown from the beginning until here, they are addition polymerizations. So this addition polymerization, where double bond extends sideways and becomes single bond. All these are addition polymerization. So when it comes to this part, making nylon, this is not addition polymerization anymore. So you can see, nylon, the use is ropes, fishing net, and line, tents, curtains. Okay, so over here, the monomers for nylon, there are 2. The first one is 1,6-diaminohexane. Okay, so amino is this one. This is amino. This is also amino. So we have amino on both sides. They call it 1,6 because this normally we put numbering like this: 1, 2, 3, 4, 5, 6. One of the amino in carbon 1, another amino in carbon 6. So that's why 1,6-diamino. 2 of the amino here. Hexane is for the 6 carbon structures in the middle. This is the monomer. The other monomer is hexane 1,6-diol-chloride. Diol-chloride is this one and this one. COCl is oil chloride. Oil chloride. So they call it di because there are 2. They call it 1,6 because this is carbon 1, 2, 3, 4, 5, 6. This is carbon 1, 2, 3, 4, 5, 6. And so the 1,6 has oil chloride. Hexane because 6 carbon. So when they want to join up, right? So they use condensation polymerization, okay, condensation, where they remove small molecule. So the amino is basic, the oil chloride is acidic, so they are like react each other through neutralization, and they remove the HCl. remove HCl. So as you can see here, the amino take H, the oil chloride removes Cl, HCl is removed. HCl is lost. So that's why this is condensation, polymerization. You don't see the double bond breaks and extend sideways. You don't see that. Instead, single bond breaks. So single bond, the H and Cl are where the single bond breaks. So this one single bond, and this single bond breaks. And new single bonds form. New single bond forms here. New single bond formed between the N and the H. So this is the new single bond. Here also form new single bonds. So the monomers are able to join to each other by eliminating a small molecule like HCl. Not always HCl, sometimes H2O. For this case, HCl. This reaction continue at each the two monomers. That means they will just continue this way also. They keep joining up. That means this side, the amino will join up with the oil chloride. This oil chloride will join up with the amino. Then they will form a very long chain, which is nylon at the end. Thousands of molecules join together, giving a macromolecules. Okay, so at the end they form this nylon. Making terylene. Okay, so terylene is clothing, the clothing material. So the clothing material which no need to do ironing on. They are always like very straight, no lines in your clothes. Especially mixed with cotton thread. The monomers are, okay, you see the monomers, benzene. This is benzene, hexagonal shapes. 1,4-dicarboxylic acid. So carboxylic acid on carbon 1, carbon 4. You know, like 1, 2, 3, 4, 5, 6. 1 and 4, we have carboxylic acid. Ethane 1,2-diol. Ethane 1,2-diol. So OH, OH. Okay, that is diol. Ethane 1,2-diol. Okay, so what happens is the OH and the carboxylic acid will react through esterifications that we learned just now. They form ester. So what they do is the alcohol will remove as in here, you see the carboxylic acid will remove OH, the alcohol will remove H. Then they remove the H2O. And after that, the C will join up with the O here to form COO, the carboxylic, the ester. So the monomer join by eliminating a water molecule. Thousands of molecules join up, giving a macromolecule. So this is where they form ester linkage. Compared with just now, this is amide linkage. This is ester linkage. Okay, so we still have a lot. Not a lot, just one page plus a little bit here. Okay, so we go through this part, then we stop. This part is just a very short and simple thing. Chalk, birds, fish, and other animals that try to eat them. You know, animals try to eat plastic sometimes, so then get choked. Or they fill up the animal's stomach so that they can't eat proper food and starve to death. So that's the plastic problem. They clog up drains and sewers and cause flooding. So plastic make the drains clog up. They collect in rivers and get in the ways of fish. Some river beds now contain a thick layer of plastic. They blow into trees and onto beaches, so the place looks a mess. Tourists become put off. So general concept, all these are pollution because of plastic. Okay, so we stop here first. We haven't finished. We still have one more page for chapter 14.